Think back. April 26, 1986. Chernobyl. The explosion.
Right. A place synonymous with, well, unparalleled disaster. We created this zone thinking it was totally incompatible with life. So toxic, so irradiated.
Exactly. We assumed nothing could really thrive there. But what if we got that wrong? Fundamentally wrong.
Because, in the years after, scientists exploring the really dangerous parts right inside the damaged reactor, they found something impossible.
Impossible? What do you mean?
Well, something was growing there, on the actual walls, right where the radiation was supposed to be completely lethal.
Growing on the reactor walls. Okay, so our mission today, for you listening, is to unpack this incredible story. Chernobyl's strangest, maybe most resilient children. A black fungus.
That's right. And it doesn't just resist the radiation, it seems to. Well, to use it. Almost like food.
Like food? That sounds wild.
It is. Ukrainian scientists first spotted it back in the early 90s, this thick, jet black mold. And the weirdest part, it wasn't just surviving. It seemed to be actively growing towards the spots with the highest radiation, like it was drawn to it.
Towards the danger. It defies all logic, doesn't it? How could anything live, let alone flourish, in conditions that just shred DNA?
Yeah, that was the big question. The breakthrough answer, it turns out, involves melanin.
Melanin. Wait, like the pigment in our skin. The stuff that gives us color and protects from the sun.
The very same pigment.
Yeah.
But in these fungi species, like Cryptococcus neoformans and Cladosporium spherospermum, this melanin seems to do something far more extraordinary.
Okay. So it's not just blocking radiation.
It seems to be absorbing gamma radiation. Think of it like a biological shield, yes, but with this incredible twist you mentioned.
So what's the twist?
Scientists are calling it radiosynthesis. It's kind of like photosynthesis in plants, using sunlight.
Right. Plants use light for energy.
Exactly. Well, this fungus appears to take deadly gamma radiation and convert it into chemical energy to fuel its own growth.
So it's not just surviving the poison, it's eating it. Making a meal out of it.
That's the hypothesis, yes. It's thriving on it.
Okay, hang on. How? How does melanin work like a tiny solar panel, but for gamma rays? That sounds impossible.
Well, the leading theory, and it's still being researched, of course, is that when that high-energy radiation hits the melanin pigment, the energy gets captured, and it's used to change the flow of electrons within the melanin molecule itself.
And that powers its metabolism. Directly.
Essentially, yes. It's a direct energy conversion from radiation to, well, life energy.
Is there solid proof for this?
Yeah.
Sounds pretty out there.
The evidence is actually quite compelling. Look at the lab experiments. They took these melanized fungi, the ones with melanin, and exposed them to radiation levels 500 times higher than normal background levels.
500 times. And
they didn't just survive, they grew faster.
Faster. With more radiation.
Correct. Meanwhile, you take fungi from the same species without the melanin, expose them to the same radiation. No increased growth. Nothing. And get this. The darker the fungus, the more melanin it had, the better it seemed to feed off the radiation.
So the pigment is definitely key.
It really seems to be. And this fundamentally shifts how we think about life, doesn't it? We always think, okay, life needs chemical energy, like us eating food, or it needs light energy, like plants in the sun.
Right. Those are the two big ones.
But Chernobyl seems to have shown us a third way, a third potential power source.
Yeah.
Raw radiation. Life that can actually live on energy we considered purely destructive.
Okay, this is fascinating on its own, but here's where it gets, really relevant for you listening, especially if you follow space exploration. This humble fungus born from disaster.
It could be vital for humanity's future in deep space.
How so? What's the connection?
Think about astronauts on long trips, say going to Mars. One of the biggest dangers is constant exposure to cosmic radiation. It's everywhere out there.
And shielding is heavy and expensive to launch.
Right. Extremely difficult. You need thick, heavy materials. Very impractical for long missions.
So you're not suggesting.
What if you could grow your radiation shield? A living shield that could even repair itself.
Using this fungus. That sounds like something straight out of science fiction.
Maybe not for long.
Right.
There was an experiment on the International Space Station. They used Cladosporium spherospermum, one of the Chernobyl fungi.
On the ISS, what did they find?
The results were pretty astounding, actually. They calculated that a layer of this fungus, maybe just 21 centimeters thick, that's less than a foot, could provide significant protection against the kind of radiation levels astronauts would face on the surface of Mars.
Just 21 centimeters of living fungus.
Enough to potentially make a real difference. Imagine, future habitats on Mars, the outer walls perhaps covered in these living fungal bioreactors.
Turning deadly cosmic rays into protection, like a living, self-healing shield.
Exactly. It's a perfect example of biotechnology, really. Using a bizarre discovery from Earth, from a place of destruction, to potentially help us survive somewhere else entirely.
So we've gone from the ruins of Chernobyl, this site of tragedy, all the way to the frontiers of space exploration. It's quite a journey for a simple black mold.
It really highlights the incredible resilience of life, doesn't it? How stubborn it is, how unpredictable. It just finds ways, turning what should kill it into sustenance.
It really makes you think, doesn't it? What other impossible life forms might be out there, thriving on things we consider absolutely lethal? And, what could they teach us about survival in extreme environments here on Earth or out there?